Hi viewers, this is Sri Ramlu. So today's topic is Compton Effect. So Compton Effect, it is the most important for the exam point of view. First, its statement: the phenomenon of change in wavelength of a scattered X-rays by a substance of low atomic number is known as Compton shift, and effect is called Compton effect. See what is its meaning? The phenomenon of change in wavelength will occur. That is the meaning. When x-rays when x-rays are scattered by what a substance which has a low atomic number. Low atomic number means like this: lithium, uh, mm, beryllium, boron, comparing to calcium, potassium. So comparing to this, its value, its atomic mass is less. And next, explanation of Compton effect. According to quantum concept of radiation, the radiation is constituted by energy pockets called photon. Constituted means contains, right? Radiations contains energy pockets are called photon. The energy of photon is h nu, where h is the Planck constant and nu is the frequency of radiation. So here energy of photon is written as h nu only. So sometimes we write it is as E is equals to h nu. The photons moves with a velocity of light c. Here the velocity of light is c. Possess means contains momentum. How much the momentum contains? H nu by c. H nu by c is the momentum. How? Why it is a momentum formula? See, momentum already we know. De Broglie wavelength is written as lambda is equals to h by mc or mv. So mass into velocity is called what? Momentum. Mass into velocity is called momentum. Okay. So this momentum can be written as p, and from this p bring this side. So p is equals to h by lambda. Okay. But we know the relation between lambda frequency and speed of light. So c is equals to nu lambda. From this bring nu this side. C by nu is equals to lambda. So c by nu, substitute c by nu in the place of lambda. Then what you get? You get what? P is equals to h by, in the place of lambda is c by nu. So c value, c by nu means nu comes upside, right? So like this, p momentum is h nu by c. Okay, momentum is simply h nu by c we write. So that is why here written. And obey all the laws of conservation of energy and momentum. Here that must obey law of conservation of energy and momentum. According to Compton, the phenomenon of scattering is due to an elastic collision between the two particles, the photon of incident radiation and the electrons of scatter. Here generally collisions are two types. One is elastic collision, other one is inelastic collision. Here in which energy and a moment, the collision in which energy and momentums are conserved. That is elastic collision. Conserved means constant. Okay, so in which collision a law of energy, law of conservation of energy and law of conservation of momentum obeys. That is elastic collision, otherwise it is inelastic. But here it is elastic collision, means energy and momentum has to conserve. Next, and here when the photon of energy h nu collides with the electrons. Okay, electrons, here let me show the first diagram how was it is. Diagram is important. See here, it is a source of x-rays and these are the collimators. So collimators also called as slits. Okay, so here which are going coming this side, those rays are stopped by the collimator and allow these rays only, and the fall these rays on scatterer, then scatter can scatter like this. So here it is a circularly graduated detector will be present that detect in which direction x-rays are scattering. If the x-rays are coming in this direction, then they are unmodified, means their frequency cannot change. Which are coming this side, they are modified. Okay, so it is a diagram, and electrons moves in this direction, photon moves in this direction. Okay friends, now when the photon of energy h nu collides with the electrons of scatterer at rest, it transfers some energy to the electrons, that is it loses electron. Suppose here electron is in stationary, then photon is coming, then what happens, this photon can collide with the electrons, then it gives part of energy to the electrons, then electron starts moving after collision, and as photon scattered in this direction, that is in elastic collision, so that is why they move like this. Okay, the scattered photon will therefore have a small energy, right? So the photon can move in this direction by giving the part of energy to the electrons, so that means it may have a certain amount of energy, smaller energy, that is h nu, and consequently a lower frequency of greater wavelength than that of the incident radiations, incident photons. So wavelength is more or frequency is less comparing to incident photon. The observed change in frequency of wavelength of the scattered radiation is known as Compton effect. So that is a Compton effect. So simply definition is Compton effect is change in frequency of wavelength uh, of the scattered radiation. So change in not a frequency, simply it is a change in wavelength of the scattered radiation. Next theory of Compton effect. Compton assumed that electron is free and is at rest before collision with the photon. Okay, so at the beginning, initially, electron is rest, photon is moving. After the collision, relativistic mass of electron is considered. Why the word has come relativistics indicates when a body is moving, then their mass changes with respect to velocity. That is called relativistic mass. Okay, here mass changes, and that change in mass can be written as m is equals to m naught by under root 1 minus v square by c square. How the velocity of the body changes, mass also changes, but this mass is mass of the body at the beginning. Okay, when it is in rest, when it is in motion, its mass becomes. Okay, this mass continuously changes. Let a photon of energy h nu collides with the electron at rest. Even If the electron is bound to the nucleus, a small fraction of h nu is used to free the electrons. So it is a nucleus. Around the nucleus, what present? Electrons present. So here electron is there. Okay, even the electron is in very nearer to the nucleus. Then what happens? Small fraction of energy will be absorbed by the electron. The process of recoiling of electron and a scattering of photon is shown in figure. So it is a diagram. In the figure, theta is the scattering angle while phi is the recoiling angle. See the diagram. Okay. Now it is a photon coming and it is an electron. At the beginning it is rest. Okay, at rest. So when it collides, photon may move in this direction, electron may move in this direction. So with the incident direction, how much photon is making angle, that is called theta or scattering angle, and electron which is making angle with this incident direction, that is denoted by phi, and phi is called a recoiling angle. Okay, recoiling angle. Okay, so here also shown clearly components of momentum before and after collision. Here components are shown, momentum component shown in this second diagram. Okay, in the first diagram also energy is shown and momentum is also shown, but it is with y direction, x direction is shown. Okay, that is the difference between these two diagrams. Okay, here no directions, only one direction, but here directions are resolved, x direction, y direction. So that is the second diagram has come. Okay, before collision, energy of incident photon is h nu. So its energy is h nu. Moment of incident photon is h nu by c, h nu by c. Rest energy, so at the beginning it is at rest, even though it has a certain mass, rest mass, that is called m naught into c square, but no velocity. So that is why it is rest, means its velocity is 0, then momentum is 0, mass of the rest electron is 0, sorry, momentum of the rest electron is 0. Okay, so these 4 points and these 4 points are important to derive the complete equation. You must remember, keep it in mind. So like this, the above 4 points are belongs to before collision, remaining 4 points are belongs to after collision. After collision, what happens? Part of energy given to the electron from by the photon. Then what happens? Photon energy changes. Why? Energy change in energy indicates change in frequency. Frequency changes. Why? Because E is equals to h nu. H is constant. We can write it is directly. E is directly proportional to nu. How the nu changes? Energy changes. But after collision, energy decreases. That is then we can say we can say frequency also decreases. So different frequency we get. So different frequency can be shown with dash. See, energy of photon h nu dash, momentum of the incident photon h nu dash by c. Okay, rest energy of mass, electron mass. See, at the here m naught c square is written, here mc square. Mc square means m is equals to m naught by under root 1 minus v square by c square. That is the meaning of m here. M means that is this is a formula. Okay, and here also momentum of the electron is mv, mass into velocity. Next, law of conservation of energy. Let me apply the law of conservation of energy. Okay, energy of photon and electron before collision. So before collision, how much? See here, energy of photon and electron. So before collision, this is and this is before collision energy. After collision energy is this one and this one. Okay, okay, h nu plus m naught c square, we have to sum them. Okay, before collision, photon energy this one and electron energy is this one. Energy of photon and electron after collision. After collision, their energy frequency changes. Okay, energy changes. Change in energy h nu dash, and mass also changes. At the beginning, it rest mass m naught. When it is in motion, mass becomes m only, mc square. Why energy formula is shown? According to Einstein, E is equals to mc square. So that is why that formula is used. Next, according to law of conservation of energy. What is the law of conservation of energy? Law of conservation of energy is energy, sum of the energy of the electron and photon before collision is always equal to sum of the energies of electron and photon after collision. Okay, that is the law of conservation of energy. So before collision, how much energy present? After collision, also same energy present. That is called law of conservation of energy. We can say like this also. And from this, see here, key mc square that side and bring nu dash this side. Okay, so new dash is brought this side. Okay, then what happens? EMC square is equals to, okay, if you bring already this side, what we have, m sorry, okay, so this side what we have already, h nu is there plus m naught c square, and if you bring h nu dash this one, then it becomes h minus h nu dash. So here h and h, if you take common, nu minus nu dash, nu minus nu dash, okay, into m naught c square. So then mc square is equals to, this is the formula. Next, law of conservation of momentum. Law of conservation of momentum. Momentum formula is same as energy. Momentum before collision is equals to momentum after collision. But here one difference is we have to observe for the energy and momentum. So energy is a scalar quantity, so that is why we cannot consider them in different directions. But momentum is a vector quantity. We have to consider it in along y direction and along x direction. So that is why here formula becomes very much big. See the what is the formula. Law of conservation of momentum along x direction. Okay, so law of conservation of energy momentum along x direction. Law of conservation of momentum means before momentum and after momentum we have to make them equal. So before momentum formula, this one already I have shown in the previous one. See here, before collision momentum is h nu. Okay, for the, it is for photon, it is for electron. And let me show once again. Here, see, momentum before collision 0, and momentum after collision is this one. So that is why h nu dash by c plus 0. Okay, next, along x direction, and see once again diagram. And see here, so it is x direction, it is y direction. Okay, and here also it is x direction, y direction. So this is resolved like this, x y x y. Okay, it is after collision, it is after collision, and before collision is this is, before collision momentum is this plus, and here it is rest means 0. So this 2 is taken. After collision, what happens? Along x direction, this one comes and this one comes. Okay, one is cos theta, cos phi. See here, see what I said, h nu dash by c into cos theta, cos phi, cos theta, cos phi come. Why cos theta and phi has come? What is the reason? How does it come? See here, now check it. So everybody know about the resolution of vectors. Resolution of vector. Suppose one body is moving in this direction with a certain velocity v. Let the body is here. Okay, so then what is its component along x-axis and what is its component along y-axis when it is making angle theta? So this concept I will implement to this one. Okay. Now from this point, draw one normal on x-axis, draw one normal on y-axis. Now if you see here, one right angle triangle. Okay, and this side also another right angle triangle. So for right angle triangle we can apply simply Pythagoras formula, trigonometric formula we can apply, and see here it is make angle theta. What I said from here to here. Sorry for the inconvenience. Okay, now it is making angle theta here. Now it is v, where from here to here it is v. Now calculate this side and this side. So let it is a b c, one right angle triangle. So AB is adjacent to the theta, BC is opposite to the theta. Then apply the sine theta. Sine theta is equals to opposite. Opposite is what? BC. This is opposite. BC by by sine theta formula is opposite by what? Hypotenuse. Hypotenuse is what? This one. That is V is given already. Okay. So now bring this with this side. Then we can write BC is equals to B sine theta. Okay friends, how does it comes? This is in the same manner, if we implement this concept to this one, then we can get above answers. Here momentum of photon in this direction is, right? So it is h nu by c. H nu by c. We have tried like this. H nu by c. It is wrong is given. Okay, h nu by c, h nu by c. So it is h nu by c. So from here to here, h nu by c. Then how much this direction and how much in this direction? That is we have to calculate. Okay. So draw one normal from this point and write it as O, A point and a B point. OAB is one right angle triangle. Okay. Now apply the sine theta. Sine theta formula is opposite by hypotenuse. Opposite is AB. So to the theta, opposite AB side by hypotenuse is from here to here. Here to here is what? This is h nu by c. H nu by c. Okay. Bring this h nu by c this side. H nu by c sine theta is equals to AB. Okay. So AB value is how much? What? H nu by c sine theta. So that is why it is h nu by c sine theta. See here, and this is c exactly parallel to this line. AB is parallel to this one. So that is why. So it is parallel to y axis. So y component is what? H nu dash by c into sine theta. Similarly, we can calculate this one also. For this, apply cos theta. Cos theta formula is what? It is adjacent by what? Hypotenuse. Adjacent is what? OA. Adjacent to the theta is OA. Hypotenuse is how much? Here to here is how much? Here to here is how much? Adjacent is h nu by dash by c. So h nu dash by c. Bring h nu dash by c this side. H nu dash by c cos theta is equals to OA. So OA term is along x direction. How much it is? H nu dash by cos theta. So like this, these two terms has come. In the same manner, for the electrons also we can calculate. This is for photon. For electron also we can calculate. So here to here value is mv. Okay. And now draw the normal here, either this side or this side. Okay. Then you can get here one right angle triangle. Okay. So when you get one right angle triangle, then apply the sine theta and cos theta. Then you can get these two components. If you apply the sine theta, you can get this one. If you apply the cos theta, this one. But here, assume it is a where this value is mv. Here h nu dash by c not given here, h nu dash by c, h nu dash by c it is. Okay friends, so like this. For electrons mv product will come for the cos phi and sin phi, and for the photon h nu dash by c will come to the cos theta and sin theta. That is you have to remember. Okay, so along x direction, one cos theta and one cos phi. Okay, how it is one cos theta, one cos phi? Check it. Along x direction mv cos phi, along x direction h nu dash by c cos theta. Along y direction it is downside upside, so then we take minus. Okay, one is a phi in terms of phi, another one is in terms of theta, both are sine but their multiplication is different. Okay, okay, just now you have seen h nu by, it is before collision, these two things are after collision along x direction. So yeah, h nu dash by c mv, and then what we get, so we get multiply on both sides with the c, then this c cancel, this c cancel, here we get one more extra c, so that is why here c, when you multiply with c on both sides then only you can get that is. Okay, from here. Okay, and now keep mvc cos phi one side and bring this side. Okay, brought like this written. Now take outside common or keep it like this only. So mvc cos phi is equals to h nu minus h nu dash cos theta. Let it is equation 2, and this for energy equation 1. Last, in the last we use this equation. And next, law of conservation of momentum along y direction. I just now have shown you along y direction sign values will come. Okay, but here minus has come. Why? Phi becomes, it is down, theta is upside. See here diagram. See, mv sin phi is downside, h nu dash by c is sin theta is upside. So it is, if it is positive direction, it is negative direction. That is why here minus is attached. See, along y direction no momentum before collision, but along y direction after collision momentum values are there. Okay, so before collision along y direction no values present, no momentum present. See here one second diagram. See, before collision this side anything is there, only one direction, that is x direction, no y direction. In this direction no this side, so that is why both values are 0 for the electron and as well as for the photon. Okay, for electron and photon. Okay, it is for electron and it is for photon after collision. Okay, 0 plus 0 we get 0, and if you have to make this value negative positive, then bring this side, it becomes positive, then this is the formula, and let it is equation 3. So equation 3 and equation 2, what we value we have, so it is a 2 equation, it is 3rd equation. Square them and add, squaring and adding equation 2 and 3, squaring and adding. So equation 2 squaring this one, equation 3 squaring is this one. So left side over, right side is C. Now it is C. Left side values, square them and add. Okay, squared and here with plus added, and right side term, so it is squared plus, and this is also squared, and plus is done. Now come here. Okay, So it is a whole square, and here also whole square we have. Then square can be implemented to the MVC also, and cos also. Here also same thing. Then here MVC we have, here MVC we have. We can take outside common, m square, v square, c square. Why? Because square is there. Okay, next inside the bracket, cos square plus sin square. That is everybody know cos square plus sin square value is how much? That is 1. Later will substitute. And see here a minus b. So let it up to here b whole square. Then apply here a minus b whole square formula. A square plus b square minus 2ab. Okay, 2ab. And the next, this is right as it is. So h nu dash whole square plus sin square theta, not plus. Okay, in multiplication we have h nu dash square into sin square theta. Next, here what value we get? Here one value, 1 into m square v square is m square v square only. And come this side as it is. It is and here h nu dash whole square is taken outside. Okay, then here what we have? Cos square theta, and here also we have sin square theta. So cos square theta plus sin square theta. Next remaining part is to this point. This is okay. Sorry, here one more time, twice it is written. It is not there. Okay, it is not there. Why? Because already common is taken. It is not there. And here also this point is not there. Okay, sorry, already common is taken here, cos square h nu dash square. Then this point and this point cannot present, only these points are present. Here this term is how much? 1. Okay, so 1 is written, 1 into this values, that value only, and squares are separated. Then we got this one. Okay, this is this one. Let it is equation how much? Equation 4. Okay, here which value you don't have to write? So here you should not write this one and this one. Why? Because here already common is taken, so that is why it cannot, these two cannot present. Okay, next, from equation 1, just now I said you equation 1 can be used in the last. So it is equation 1. Square it on both sides. So already you see square is there, mc whole square, again make it whole square, and again separate it. It is what? Let it is a plus b, a square plus b square plus 2ab. Okay. Okay, now once again separate it. It is also again in the form of a minus b whole square form is there. Okay, so separate it, keep it a h square outside. A square plus b square minus 2ab, 2 nu dash. Next it is as it is. Okay, this is also as it is. And the next, h square is multiplied inside. That's it only, it is separated. Now let it is equation 5, subtracting equation 4 from equation 5. So subtract 4 value from this, so that means 5 minus 4, equation 5 minus 4. So what is the equation 4? This is the equation 4. Okay, and equation 5 is what? This is the equation 5, bigger one. Okay, subtracted. Here equation 5 term is this one, equation 4 term is this one. So left side values are subtracted, similarly right side values. This equation 5, it is completely equation 5 minus equation 4. Okay, and here written as it is, same copied. and once again come this side here. If you multiply this minus value, it is minus, this is minus, so minus term and plus term cancel. Okay, h new h new dash square, h square new dash square, h square new dash square, minus minus minus, and it is plus and minus cancel. This minus become, it is plus. Okay, so write remaining terms. Oh, once again it is separated, once again separated. So this is cancelled, this is cancelled, this is, and this one and this one cancelled. Why? Because those two are plus, these two are minus, and the remaining terms, this is, and this is, next this one copied, and next this one is copied. Okay, keep it like this aside. And we know that, just I said in the beginning of this topic, m is equals to m naught by under top 1 minus v square by c square, I said you. So square it on both sides. Squaring, what happens, what we get, m square m naught square by, here root cancel, so root without root. And next time is c square common here, c square, take LCM c square in the denominator, then what happened here, c square by c square goes upside. Okay, so multiplying with c square on both sides, then what you get, already c square is just c power of 4, it becomes, so this side no c square, so c square percent on both sides. Okay, now see here, m square c square, in the place of m square c square, it is can be replaced with this one. Okay, so for this only it is taken, so in the place of this is substituted here, and is as it is, remaining all are same. Okay, now what happens, this c square minus c square and c square minus v square gets cancelled. Okay, now what you get, this only we get, and this side as it is. And next step is, the next step, this m naught c power 4, m naught square c power 4, m naught c power c square power 4, so these two gets again cancelled. This side nothing means it is 0. Okay, all are get cancelled this side, so that is why it got cancelled, so that is why this side a 0. Okay, so 0. Next, what is present, it is already cancelled, this one it is written, and this is written, and this is also written this side. Now, so bring this is this side, it is already plus, if you bring this side it becomes minus. And now, okay, 2, so in all, see 2 h, here 2 h square among h square h will cancel, 2 h square among h square h will cancel, so this side hs will present, but h completely cancel. Okay, here h is present, here h is present. And now can cancel minus also, so here minus is taken outside. What is taken, minus h new dash is taken outside, then it is what, 1 minus cos theta. Okay, when you take h minus h new dash common outside, then only here 1 minus cos theta we get. And see here, among the m naught c square can be written at like this, c square is written c into c, so bring these two terms this side only, keep c this side only, so c is here, so c is here, m naught c is brought this side. Okay, and new dash is brought this side. Okay, so then already h is there, and from this side m naught c comes h by m naught c. Okay, now separate this one, new by new dash minus new dash by new dash into c, h by m, same it is as it is. And here new cancel, and here new dash cancel, then we get this one. Okay, and here I am not changing anything this side. Next, multiply C value inside. So it becomes C by nu dash C by nu. So C by nu can be written as lambda. If you have C by nu dash, write it as lambda dash. Okay. So lambda value is C by nu is lambda. So C by nu is lambda. But here C by nu dash is there. So that is lambda dash is written. And lambda dash minus lambda is called change in lambda, that is denoted by delta lambda. Okay, is equals to h by m naught c 1 minus cos theta. So this delta lambda is called Compton shift, and it is equals to h by m naught c into 1 minus cos theta. Now again we can write in another form also this form. So everybody know that is 1 minus cos theta is what? 2 sin square theta by 2. In the place of this 2 sin square theta by 2, then we get this one 2 h by m naught c sin square theta by 2. This is also called as Compton shift. And change in wavelength, this change in wavelength due to scattering is called Compton effect. Like this, Compton effect. Now this is the formula. So for this special cases are there. When theta is equals to 0, what happens? Theta 0 means sin 0. Sin 0 value is how much? 0. Then 0 into everything is 0. So delta lambda is also 0. So that means there is no scattering along the direction of incidence. That means suppose x-rays are coming like this. If they are not going in this direction, if they move in the same direction, then what happens? Theta value is 0. If they move like this, then theta value is there. If they're not, there is a scattering like this, then what happens? Only they are moving in the same direction, then theta value is 0. Now if the theta value is 90, theta value 90 means what? Incident direction is this one. Then if the photon scattered exactly like this, then how much angle here? 90 degrees. Substitute here in the place of theta 90, already by 2 is there. Here pi by 2, pi theta value pi by 2. So pi by 2 is pi by 4. Okay, pi by 2 by 2 is pi by 4. Pi by 4 sin pi by 4 how much? 1 by root 2. Okay, 1 by root 2. And here sin square is there, so make it square. It becomes 1 by 2. 1 by 2. Okay, how much value you got here? For this 1 by 2 you got. So already how 2h by m naught into c is there into 1 by 2. These two gets cancelled. So what is m naught by c value is there? Okay, m naught by h by m naught into c value is there. So h value we know, this is m naught value in mass of the electron, c is the speed of the light, it is in terms of meter. Then in terms of angstrom values, by simplifying this we get 0.02426 angstroms. This difference in wavelength is known as Compton wavelength. If theta value is 180 means what? So scattering, suppose initially x-rays are moving in this direction. If they scatter along the same direction but in opposite, then theta value is how much? Pi value. Substitute theta value is equals to pi in the place in the above equation. Here if you write in the place of theta pi, already by 2 is there, it becomes 90. Sin 90 value is 1. Okay, 1 square is 1 only. So then 1 into 2 h by m naught is m naught c is same, 2h by m naught c. Then what happens? We get this is the answer. Okay, so wavelength is increased. Okay, when x-rays are scattered with a 180 degree, wavelength becomes double. So it is a wavelength of when 90 degrees, and it is wavelength in when 180 degrees. So it becomes double. Okay friends, don't forget subscribing this video and watching this video till the end. Thank you friends.